There is a version of Tesla that everyone agrees on. You have seen it. The car that made electric vehicles feel inevitable. The company that turned charging stations into a status symbol and convinced millions of drivers that gasoline was already obsolete. That is the Tesla people know. That is the Tesla people argue about at dinner tables and in comment sections. But there is another version of Tesla growing quietly in the background, one that has almost nothing to do with drivers, roads, or the way you get to work in the morning. And if you have not been paying attention to it, you are missing what might be the most important business story hiding inside a company you thought you already understood. Here is the thing that should stop you cold. In 2025, Tesla's vehicle business generated $69.52 billion in revenue. That sounds enormous, and it is, but vehicle revenue actually dropped 10% compared to the year before. Sales grew only 6%. Margins were shrinking. The car business, the one that made Tesla famous, was slowing down. Meanwhile, a completely different division inside the same company grew 27%, generated $12.8 billion in revenue, and in the third quarter alone posted a 44% year-over-year increase. That division does not build cars. It does not build chargers. It builds giant batteries. And its fastest-growing customer is not a driver. It is a data center running artificial intelligence. That is the contradiction at the center of this story. Tesla became famous because of drivers, but one of its fastest-growing businesses may now be helping artificial intelligence infrastructure more than the people sitting behind the wheel. To understand how that happened, you need to understand a product that most Tesla owners have never heard of and most people outside the energy industry have never thought about. It is called the Megapack. Picture a shipping container. Now make it massive. Fill it with enough lithium-ion battery capacity to store 3.9 megawatt-hours of electricity. Pair it with a 1.5 megawatt inverter and give it autonomous grid, forming controls that can respond to power fluctuations faster than any mechanical generator on Earth. That is a Megapack. It is not a consumer product. You cannot buy one for your garage. These are utility-scale machines designed to be deployed in multiples across large industrial sites, stabilizing power grids, storing cheap off-peak electricity, and releasing it during moments of peak demand. A single installation covering just 3 acres can deliver 250 megawatts and 1 gigawatt-hour of storage capacity. That is enough to power a small city. And right now, the customers buying these systems at the fastest rate are not utility companies looking to modernize aging grids. They are the companies building the infrastructure of artificial intelligence. To understand why, you need to understand what artificial intelligence actually requires. Not the software, not the algorithms, the physical reality underneath all of it. Every time a large language model processes a question, every time an image generator renders an output, every time an AI system trains itself on billions of data points, it is drawing electricity. Enormous amounts of electricity. From servers packed into massive buildings, running 24 hours a day, 7 days a week, generating heat that requires more electricity to cool. In 2024, data centers consumed 415 terawatt-hours of electricity globally. By 2030, that number is projected to reach 945 terawatt-hours. That is more than double in 6 years. Goldman Sachs projects a 165% increase in data center power consumption by 2030. The Electric Power Research Institute estimates that artificial intelligence demand alone could top 50 gigawatts in the United States by 2030. That is 10 times the current level. For context, 50 gigawatts is roughly equivalent to the entire power consumption of California and Texas combined. And here is where the story gets genuinely strange. The artificial intelligence boom did not just create a demand problem. It created a specific technical problem that almost nobody anticipated. When large clusters of graphics processing units, the chips that actually run AI training workloads, cycle through intense computational tasks, their power consumption does not stay steady. It swings violently. Power loads inside an AI data center can fluctuate by up to 90% within seconds as GPU clusters spin up and down. That kind of variability does not just strain a power grid, it breaks conventional backup systems. Traditional diesel generators and mechanical turbines cannot respond fast enough. They are built for steady loads. They are not built for a situation where the demand for electricity doubles and then halves and then doubles again within the same minute. The engineering problem is not just getting enough power to a data center. It is delivering power that is stable enough for the machines inside to function reliably. And that is exactly the problem that a Megapack was built to solve. A battery energy storage system responds to power fluctuations in milliseconds. It does not need to spin up. It does not need fuel. It does not need time. When the grid hiccups or the GPU cluster surges, the Megapack is already compensating before any mechanical system would have detected the problem. Tesla's own data suggests that Megapack installations can reduce the kind of power oscillations caused by AI workloads by up to 90%. That is not a marginal improvement. That is the difference between a data center that functions reliably and one that faces constant risk of equipment damage or operational failure. The clearest proof of this connection is not a forecast or an analyst prediction. It is a real project in Memphis, Tennessee, on a road called Paul Lowry Road, in an industrial area that most people have never heard of. That is the location of Colossus, the supercomputer being used by xAI, Elon Musk's own artificial intelligence company, to train the Grok AI system. When xAI needed to expand Colossus from an 8-megawatt facility to a 150-megawatt operation, they faced an immediate power reliability problem. Their initial solution was to install 35 on-site methane gas turbines with a combined capacity of 422 megawatts. After that decision generated significant community opposition and environmental concerns, those turbines were removed. What replaced them was 168 Tesla Megapacks, managing outages and demand surges, and providing the kind of instant, stable backup power that a facility training one of the world's most advanced AI systems requires. The company building the AI and the company selling the batteries are both connected to the same person. But the underlying logic of the transaction is purely technical. Megapack solved a problem that gas turbines could not solve cleanly, and xAI has plans to eventually scale Colossus to 1.1 gigawatts of total energy requirements. That project is the one everyone can point to because of the names involved, but it is not the only example. In Tahoe, Reno, Nevada, at a campus called the Citadel, the data center company Switch deployed an 800 megawatt-hour Megapack installation paired with 555 megawatts of solar generation to power a facility consuming roughly 130 megawatts. Store the solar energy during daylight. Release it when the sun goes down. Keep the data center running without interruption. In Texas, within the ERCOT power grid, a 130-megawatt, 260-megawatt-hour Megapack installation provides grid stability specifically for data center battery storage. These are not hypothetical future deployments. They are operating right now. The executive acknowledgement of this shift came from Tesla's own VP of Energy and Charging, Michael Snyder, during the company's third quarter 2025 earnings call. His exact framing was that demand for Tesla's products is strong heading into 2026, and he specifically cited remarkable growth in demand from data centers. His explanation was direct. The artificial intelligence boom has fueled a need for more energy, which data centers use to train and run their models. When a company's vice president uses the phrase remarkable growth in a specific customer segment during an earnings call, That is not casual commentary. That is a signal about where the business is going. The deployment numbers back that signal up completely. In 2023, Tesla deployed 14.7 gigawatt hours of energy storage. In 2024, that number doubled to 31.4 gigawatt hours. In 2025, deployments reached 46.7 gigawatt hours, a 48% increase over the previous year. The third quarter of 2025 alone, at 12.5 gigawatt hours, was the largest single quarter of deployments in the company's history. Tesla's chief financial officer publicly forecast at least 50% year-over-year growth in deployments for 2025, and the actual results came in above that pace. Tesla's Shanghai Megafactory is now running at 40 gigawatt hours of annual production capacity, targeting 10,000 megapacks per year, and the company produced over 2,000 megapacks in 2025 alone on the way to that goal. And here is the financial reality that most people are not discussing. Energy storage products, including the Megapack, the Megablock, and the residential Powerwall, drove nearly a quarter of Tesla's total gross profit in recent periods. The energy division, despite being roughly a sixth the size of the vehicle business by revenue, is approximately twice as profitable per dollar of revenue. The vehicle business, for all its scale, is facing margin compression, price competition, and slowing growth in key markets. The energy business is facing a demand curve that one industry analysis described as a multi-generational rise in electricity consumption. If current trajectories hold, Tesla's energy segment could be generating between $40 and $55 billion in annual revenue by 2030. That would be a number approaching the size of the entire company today. Now, for the part of this story where honest skepticism belongs. Tesla is not the only company building utility-scale battery storage. Competitors, including CATL, BYD, Fluence, and others, are all competing for the same data center contracts. Battery supply chains have their own constraints and vulnerabilities. Utility procurement processes are slow and complicated. The data center build-out could face its own financial recalibration if AI investment cycles pull back. And the connection between Tesla's energy business and artificial intelligence infrastructure, while real, is still developing. The company still generates the vast majority of its revenue from vehicles. None of this is guaranteed. The question worth sitting with is not whether Tesla will dominate energy storage. It is whether the market opportunity is large enough and structurally durable enough to matter, regardless of market share. Bloom Energy projects a 35 gigawatt energy gap by 2030 between supply and demand in the grid-scale storage market. Multiple infrastructure analysts estimate that each gigawatt of new data center power load requires significant battery storage backing. The numbers suggest the opportunity exists independent of any single company winning or losing. Elon Musk made a comment in a public conversation that carries its own weight here. He said people are going to start hitting challenges with power generation maybe by the middle of next year, end of next year, referring to mid to late 2026. Whether or not that timeline is precise, the underlying concern is real and documented by organizations with no stake in Tesla's stock price. The Electric Power Research Institute, Goldman Sachs, Deloitte, Columbia University's Energy Policy Program, Bank of America, McKinsey, all projecting versions of the same fundamental story. AI needs power. The grid is not ready. The gap between demand and committed supply in major grid regions is already measurable in the tens of gigawatts. Someone has to fill that gap. Here is the question worth asking yourself and worth leaving in the comments below. If the real bottleneck for artificial intelligence turns out to be electricity and not algorithms, which companies actually win that race? Because the companies building the models need the companies building the power infrastructure. And right now, Tesla is one of the few companies that has already deployed the technology, built the manufacturing capacity, and landed the contracts at the scale that story requires. Tesla may continue selling millions of vehicles. The car business is not going away, but something worth noticing is happening inside a company most people thought they already understood. Because while the public conversation about Tesla stays focused on cars, autopilot, and price cuts, one of its fastest growing revenue streams is being driven by something most drivers will never see: a massive battery system humming quietly in an industrial park, keeping an artificial intelligence supercomputer running through the night. That is not the Tesla that made the company famous, but it might be the Tesla that matters most to what comes next. And as the world's appetite for computing power keeps growing, the story of who supplies the electricity behind it is only getting started. If you want to stay ahead of the shifts that will actually change the industry before everyone else figures it out, joining this channel is the best place to do that.